Okay, this is chapters 7 and 8. We combine two chapters. It's basically chemical reactions, which will involve balancing and also knowing how to actually create a reaction. Alright, so on the screen you will see some evidence of chemical reactions. Visual clues are the easiest because it's what you're looking for when you go into the lab, right? So you'll see a color change, a solid formation. If a solid forms when you put two liquids together, that's called a precipitate. Bubbles might be produced, which is an indication that gas was produced. And you also might see a flame occurring, okay? Non-visual clues are basically temperature changes. So heat can be produced, so the temperature would be hotter, or heat would be absorbed, in which case the temperature would be colder. Like an ice pack, when you break the ice pack, there's two chemicals in there, they mix together and you feel the coolness. But that is heat being absorbed. Alright, chemical equations. Okay, first thing, chemical change you learned in the very first chapter, and this is just a reminder that you are just rearranging the way atoms are grouped. Okay, you're not creating anything, you're not destroying anything, you are basically rearranging. A chemical reaction itself is one or more substances changed into one or more new substances by what? Reorganizing atoms, which is the same thing as rearranging. Now, the equation itself is something where we use formulas to show chemical reactions. So you'll see an example on the screen, the CH4 plus O2, and that arrow means to yield CO2 plus H2O. And what you need to be familiar with now are those names. The left side are the reactants, get it, because they are reacting, and the right side are the products because something is produced. Okay, this law should look familiar. You've learned this several times. This is the law of conservation of matter. Atoms are not created, they're not destroyed, but they do need to be accounted for in all the products. So if you are rearranging them, you should be able to show that that rearrangement is balanced. So if the reactants and products do not equal each other, you will have to balance that equation. So to balance, we use what's called a coefficient, which is a number that is placed in front of the formula. So if you look at this same equation, if you see the 2 in front of the oxygen and the 2 in front of the water, those were placed there because the equation on its own was not balanced. Okay, these are some symbols that you might see in looking at equations. S is for solid, L is for liquid, G is for gas, AQ is for aqueous, which means it's dissolved in water, and the triangle represents heat. Alright, diatomics. These are actually placed on that pink sheet that I provided, so you don't have to memorize these, but you have to remember to use them, and the fact that they occur together. I like to call these twins, because just naturally they occur with their partner. So you have H2, O2, N2. That's where the honorable and honorable 7 comes from. F2, Cl2, Br2, and I2. And the 7 comes from the fact that there are 7 diatomics. F, Cl, Br, and I are in group 7. And then they also make a formation of the number 7 on the periodic table if you actually look at them. Alright, now here we have some examples. Okay, so let's look at some examples here. Okay, to balance our first one, you have to look at each side. Hg and Hg, if there's no number that's 1 to 1, they are balanced. O, there's 1. O, there's 2. So to fix this, you put a 2 in front of the entire compound. Never should a 2 go here. That is not a coefficient. Okay? But you should notice now that the 2 now affected the Hg. You now have 2 of them, so you need to place a 2 on the right-hand side as well. This is now balanced. Make sure never ever put a number here. Next one, carbon, carbon, balanced. O2, O2, balanced. This one is done. You don't need to add anything, and don't expect too many of these. They're too easy, but sometimes they will be balanced. Okay, you don't need to put ones, nothing. It's finished. Next one, Zn, Zn, balanced. One of my recommendations is to leave hydrogen for the end because he tends to be a troublemaker. He'll show up in many spots, so we're going to leave him for the end. Cl, Cl2. So to fix this, you put a 2 in front of the entire molecule. And you should notice now that that now changes your H. So 2 H's, 2 H's, it's done. Okay, now you've got a hard one. Okay, this is always one of your toughest equations to balance. It's a combustion reaction. We see the production of water, H2O. But nonetheless, how do you solve this? Again, we just work from left to right. 2 C's, 1 C, put a 2 in front. Okay, I told you to leave the H's for the end, but you've got another troublemaker in this problem. It's oxygen. So for me, oxygen is always last. No matter what you've got, put him at the end because he will be in a variety of spots and that makes him tough to balance. So let's try our our H's. So you should notice 5 plus this one that's assumed to be 1. That's a total of 6 H's, right? You have 2 H's on this side. So how do you make that 6? Put a 3 in front because 3 times 2 is 6. And I'm going to get rid of this. Okay, now let's check our oxygens. You have 3 here, and you have 4 here. So that's 3 plus 4 is 7. Now you've got oxygen in 2 different locations. So the recommendation is leave this odd one by itself and try to work on this one. So if you place a 3 in front, 3 times 2 makes 6, plus this one right here makes 7, and now it's balanced. Alright, and the last one here, H2. H2 is good. O2, only one O, not balanced, so please put the 2 in front of the entire compound. That makes our O's balanced, but now your H's are off, so make sure you fix that by putting a 2 in front. So make sure you do practice all my balancing handouts. That's the best way to understand this, is just to keep practicing.